Hello and greetings, and um, just wanted to introduce you all to the what I'm going to be looking for as part of your screwdriver tool project submission. Um, and so normally I would again do this during class, but since we don't actually meet in person this time around, I'm going to show it to you, what I'm going to be looking for. If once you email it in, what am I going to be looking at? And so first off, of course, you need to look at the video, but there's also all the other guidance that goes along with it. So um, if you'll notice here, we start with the screwdriver project. Read these things. Do the videos, yes, and do them at the right pace so that you don't miss anything. Because if you do, then you have to go back, and all that time that you saved by going too quickly, you just lost and lost even more. So make sure you just go through it carefully, and then you'll actually save time. So notice how we've got some checklists in here to consider. I have some PDFs that you can use to refer to these things. You don't have to make these drawings unless I actually tell you, but these are for reference, okay? So we've got the square and the hex shaft. These are easy, but here are the screwdriver bits. Notice that there's a mistake in one of the videos that shows you 6.5. If you make it 6.5 millimeters, I will know for sure that you haven't been reading like you're supposed to. I have it cross. So we've got a whole bunch of guidance here. This is stuff that students have asked over and over and over again, and enough times that I actually put it in here. So if you find something that doesn't seem right or that you've got a question on, go here first because it will probably be covered here. That's a real good chance. I'm going to say 90 to 95% chance that all your questions are answered in the video or right here on Blackboard. And here's a nice, great big picture of the hex that I created. Again, I don't have a video for it. You're supposed to use what you learned to create that. Showing some diagrams there. And continuing on all the way to the end, including the submission instructions. Now, notice that for the screwdriver, there are two assemblies, two drawings to do. So I have a video for one, then you're supposed to take that and apply it to the other. And that's the shaft subassembly. All right, so let's go there and see what I'm going to do. Okay, so a student just emailed this in, not really, but I'm going to tell you what I'm looking for. Okay, so this is an assembly. This is the main assembly. So I'm going to make sure, number one, that it has the way it has the structure it's supposed to. It has the handle, of course, and then the shaft assembly. This thing right here. Now, some people somehow think that you're supposed to put the handle and the assembly together and then make another assembly. That's not how it is. I have the flathead, the Phillips, and the hex all right here in the same assembly. So this assembly should have 4 parts and 1 subassembly. And so if you go to my checklist here, that's it. Save your name and the file name. Did you file it carefully? Use anti-dimensioning and so on. Um, created an axis for reference. Okay, that's for the handle. I'm sorry. Let's go down to the full assembly. Name and file name, video. Um, so notice how I've got 4 parts and 1 subassembly here. Now, in each one of these parts or models, if you will, has 3 mates to it, 3 coincident mates, all just using planes or sometimes the flats on the inside, but not the flats here. Maybe the one at the very base, but not that here. So there should be a tiny gap all the way around here. And we should have 4 configurations, the dash 00, the dash 01, the dash 02, and the dash 03. So you see that right here, 00, 1, 2, 3. And if I double click on them, notice how that's the flathead, that's the Phillips, and that is the hex. Okay. If I actually go here and I go to properties, it shows up right here in the description. and that's going to be reflected later on in the bill of materials. Okay, so I'm going to look for those, and then I'm going to look for the mates. Okay, notice how these 6 are always there because they're the mates for the handle and the shaft. And then these 3 are for the flathead. These 3 are for the Phillips head, which of course are not shown for this configuration. But then these 3 are for the hex, and that's shown in this configuration. So I'm going to be looking for that. I'm going to be looking, make sure that there's this tiny gap right there. See that right there? That tells me that all the way around that you actually have it centered inside, that you didn't mate these 2 faces here. That's not the way it's intended. It's intended for them to be centered on those planes. All right. So that's the main thing I'm looking for here. If I don't see those mates, I might start doing weird things like dragging this around. Now, do they have to be exactly all these coincidences? No, as a matter of fact, they don't. There are other ways of doing it, perfectly acceptable, but make sure that this stuff doesn't spin around. Because if I can take this and drag it and spin it around, then you didn't fully do it. So I'm going to definitely be looking for that. Okay, you might actually have 15 coincidences here, but you might not have the right ones or not enough or whatever. You might have some duplicates, in which case some of these are going to move or slide back and forth. They all need to be perfectly set in there so they don't move. Okay, let's go look at the parts. I'm going to look at this flathead. I'm going to bust open these sketches, see what you got. Okay, this is going to be 6.35. That's the way it should be. Okay, and everything looks good here. Now the cut here. Okay, notice how I have 1 millimeter. Again, we're using millimeters down here. 1 millimeter across the center line. Okay, now you may have made an axis or something like that. Make sure you're dimensioning across the center line. Otherwise, you're not going to get this cool dual feature. You're going to end up with a 0.5 something. Don't do that. Nope. We want it 1.0 across. And I can explain to you why, but I'm not going to right now. This dimension here is 10.7. That's all you need. This arc is black. Notice I don't have just the arc, but I also put these lines in here. That's good form and helps the computer understand what you're intending to do. Here, over here is the center, and this needs to be aligned properly with this edge right here. Okay, so I'm going to be looking at that, and then I'll just check out the mirror, make sure you did that right. That's not too hard, and it's pretty obvious when you do it wrong. And then these fillets. Notice how these fillets come up to here and stop. You don't have any of the edges filleted. Okay, here we go with the with the Phillips head, and immediately I see a problem. I'm gonna hide those planes for a second, and that is this thing. Well, this should not be here. So I've got to figure out what's going on with that. So I don't even know, but there's already something else that's wrong. 6.5 across the flats, not supposed to be there. This is supposed to be 6.35. Okay, there was a mistake in the video. Sorry, that happens. So that's why I put that in the guidance. So if you don't want to be canned for my mistakes, there you go. Now, this is still an issue. So I'm going to go to here and see if I already took care of it. So I'm going to open up the feature, and the selected contours thing, I'm going to delete it. If it goes away, then yep, the computer made some weird assumption, and now I'm good. Okay, so that's what I needed to do on that. All right, now I'm going to look at this from the side. I'm going to look at each one of these planes and see how far that one is. That's 11.80 or something like that. Okay, 11.80, and then this one is 12.70, and so that's 23.5. So that might even be wrong, but that's okay. So make sure that those are all correct. So then I'm going to look at each one of these sketches. There's sketch 2. There's sketch 3. Now notice on sketch 4, it's got this little hand thing, a little hand. That means it's being shared. There's a little hand here, a little hand here. They both say sketch 4. It's being shared between two features, and that's fine. That's okay. So that little symbol is okay. All right, that other one that we had, not okay. All right, so let's look at sketch 4. That's just another circle, right? And it is somehow, there's a dimension on it somewhere. All right, well, there's supposed to be a dimension on it somewhere. Up there. Okay, that's what it is distance-wise. And I think it's dependent on sketch 3, perhaps. Oh, there it is. There's sketch 3. Okay, so sketch 4 is dependent on sketch 3. That's why. Okay, so I want to make sure that I got those dimensions down. So now I already looked at sketch 4, so I'm going to look at sketch 5 here, and I'm going to make sure that you only use one dimension here, the 1.27, and that you've got 4 gajillion green symbols all over the place. And I can see that this is symmetric, and that one is co-radial. Bet you didn't think we'd be using that, but we do use co-radial right here. And that one's horizontal, and so on. Another symmetry there. All right, so done with sketch 5, which is the craziest one. Sketch 6. All right, and so I got 2 dimensions here, 51 and a 76. All right, and everything looks good on that. And then the fillets. Okay, so this is fillet 1, and that's fillet 2. I won the filleting wars here because I only used 2. It's pretty good. You might wrestle with them a lot more than this. Good luck with that. All right. If you do need help with that, let me know. But you're supposed to find out that filleting is a royal pain in the tuchus. All right. Hex insert. All right. So this is mine that I made up. And notice I've got the right dimension here, 24.1. I just threw that one in there to show you what it's supposed to be. All right, and I've got all these opened up. Ooh, there, yes. Make sure I've got the 6.35, which is the proper size. All right. And can show these planes. All right. So I'm looking at all these planes. Notice how these two are really close. That's how I got that nice edge going on right there. All right, so got the loft. Let's go with sketch 3. Sketch 4 should be a circle. There it is. And sketch 5 is also shared with the next loft. Okay, so sketch 5 is down to circle. So I went from hex to circle. Now I put another circle in there so I could help work on the insides, but I did it the same way as the Phillips. All right, then I went from the opposite direction. I went from sketch 7 to sketch 5, but that's okay. So here's sketch 7. It is a hexagon. Okay. And then that went back towards sketch 5. All right, and then here's sketch 8. Now this I did as a loft. You didn't have to do it as a loft. There's another way of doing it. It's actually a better way of doing it, but I'll let you figure that out. Now, if you'll notice here, I lost the filleting wars. Look at how many times I had to try different fillets individually instead of getting them all in. So sometimes these fillets are very difficult and really annoying. So fillets like 10 mean nothing or something like that. Okay, and there's the chamfer that I made. Okay, for whatever reason, I put an axis in at the last. You don't have to do that. I probably did that to show somebody one day. All right, so I'm going to make these invisible again. All right, so that's my hex. So I'm going to make sure that all those things. Oh, wait a minute. One more very important thing on that. All right, part of the assignment is to make sure that this cross section here never gets narrower than the rest of it. But guess what? It does. It does. It just slopes down a little bit here. And if you'll notice on the checklists, I actually show that. There's the assembly. Here's the flathead checklist. Okay. Oh, I must have done that wrong. So all right. And the where'd it go? Here's the hex. Okay. So I'm showing you right here. This is not what you want. So let's go. Whatever that was. All right, so we've got this issue here. So the problem I have here, I believe, is sketch 4. Yeah, here it is, sketch 4. It's at 5.5. So there are a variety of ways of dealing with this. I'm just going to increase the diameter of this. Sketch 4. All right, I'm just going to have to edit the sketch here. I'm going to try to edit the sketch here. There it is. So just bump that up to 5.7. And if you'll notice now, this slope continues to go outwards and never constricts. This is going to be better when it comes to stress relief on this part. So there we go. So we improved the stress factor, the stress concentration here just by clicking a couple of things and changing a number. All right, let's go to the shaft assembly. All right, so on the shaft assembly, notice I just have the two parts, square and the hex, and how are they connected? Okay, first I want to, there's this whole assembly part, or assembly file here, and it comes preloaded with the front plane, top plane, right plane. We want to get that in there first, so everybody's referring to the same stuff. We're on the same page. So I do that with the square first. If I drag this out, you can see things a little bit better. Shaft square example to the front plane, shaft square to the top, shaft to the right, okay? And now, if I look at the hex here, I've done the hex to the shaft, hex to the square, hex to the square, hex to the square, and because that's how it's going to be assembled or put on or something like that, okay? So 3 for the one, 3 for the other, everything's where it belongs. So I can't drag it anywhere, I can't drag it off, I can't rotate it, any of that stuff. So that's good. Pretty simple, that one. Okay, so now I've got this drawing here. Now I show you how to do the drawing, and it's amazing how quickly you can get one of these drawings done in such a short period of time. But sometimes people get a little stuck on this bill of materials. One thing on this quantity, if you want to right click on it and it says show on call, if it doesn't show all configurations, then those numbers go away. So right click on it and show all configurations. That's something people ask questions about all the time. That's new from a couple of years ago, so that's why it's not shown in the video. All right, then make sure you've got the right thing pointing to the right thing. So one to this, and these things should be in the proper order. So this is item number here. It's in all of these. So the handle is in all of them. The shaft assembly is in all of them. But -00 does not have any inserts. dash 01 has just Flathead, dash 02 has just Phillips head, and dash 03 just has that. So it should show those kinds of things. So here's our assembly or our configurations up here, and here are the part numbers themselves that are shown. All right. That being said, if maybe your part numbers are kind of screwed up and they're in the wrong order, you can literally just drag that around. Notice how I just made that and it changed the numbers here and all that stuff? I don't want to do that though. I want that to be back up there. So, yep. So make that go up there. Okay, so I'm back in order. 01, 02, 03, and everything is back the way it should be. Another big thing though on this is these two items. So I'm going to edit the sheet format and I'm going to look at these. Notice how if I roll over this, it shows that it doesn't show screwdriver assembly. It shows that there's some kind of metadata involved here. Same thing with this, some kind of metadata called the part number. Okay. And you get this, as I show in the video, by using this thing, which is linked to property. So make sure you use that metadata for that, because I will definitely be checking that. Don't try to snowball me and do something different. Ask if you can't get it, okay? Ask me, ask Keegan, whatever. All right, but I'm here a lot. Just log into my office hours. Hopefully I'm going to be there, or send me a note saying, hey, I'm almost ready, but I've got a few questions. Perfectly legit. I expect that, all right? Okay, so going back to edit sheet. That's pretty much done. I think I've got a PDF that you can compare everything to, so this should work out. All right, next, shaft assembly. Okay, so this is the drawing that you're supposed to do. So you're supposed to use this example on a much simpler thing of the assembly of the shaft, the square part and the hex part, and those put together. So, bring all the stuff in, but not, not bring that assembly in. Just a very simple shaft assembly in here. Show a couple of views, show a couple dimensions, put in a bill of materials, put in the ballooning, even though there's only two parts. That's fine. You got to do it. You got to show that if you want to tell someone how to put it together. And then the same stuff with the format. All right. And one thing about that is that if you do this dimension, which you should do, it's probably a good one to do, this going from here to here shows 9.17. It's not 9.17. You should be able to calculate very easily, looking at the model, what it's actually supposed to be. All right. And don't forget, we're in millimeters down here. So click down here, make sure it's in millimeters. But I'm going to zoom way in on here and give you a hint. Note how this is not actually pointing at the tangent here. So my question is, what's going on? All right. It might look at like it's hitting the tangent, but it's not actually hitting the tangent. All right. So I didn't do the rest of the drawing over here. I just showed you this. All right. Next, screwdriver handle example. Okay. Of course, I'm going to look at these sketches. First one's kind of interesting. And I'm going to look at all those dimensions. Notice I'm definitely going to look at whether these are diameters across that center line. This should be a full half dimension, 27. Key thing is here, make sure that this is a straight line that's tangent to this curve. Everything else should be pretty good. All right. Next, the cut, the one that you guys hate very much. Oh, sorry, wrong cut. Now this one's pretty good. Yep, 6 millimeter, straight up, square, good to go. But this one is the one you hate. Okay, but I'm just going to check this to make sure you've got all the little details in here. All you have is the one dimension. You've got these relations going on. And for this one, hey, if you can't get it right the first time, try it again. It might be easier the second time around. And if you waste too much time on it, or don't waste too much time, please try to ask for help. And if you can't get something the first time around, yeah, not the first time, but the 8th time around, let's move on to the next part, ask for help, and we'll get back to it, okay? All right, next. So here's this part again. So I'm gonna look at these sketches. Of course, this one's pretty easy. You got the 6mm, and then you've got these guys. So it's 1.5 above. So by this time, you should be able to calculate in your head what it is from tangent to tangent and why it's not 9.17. Just looking at the mirror here and then looking at the fillets all the way around. Okay, pretty simple. And one more is left. This one's also fairly simple. Now to do the weld, I think I forgot to mention the weld on the other one, but to do the weld, it does help to remove just this edge, just the rounds on this edge, and leave the ones inside. All right, so I'm going to go back to that shaft assembly. Okay, so notice up here I've got the weld folder. I'm going to look at that. All right, and there it is. Notice how it's hidden here. I'm going to unsuppress it, and I'm going to look at that. All right. Now you're probably asking, well, where is it? Where is it? All you got to do is go up here to the little eye thing, go down to this spot here, and there is that weld bead. All right. Then you ask yourself, what's this stupid thing coming out here? Now, I can understand that you don't always want to show everything because of processing power, because it's ugly, it gets in the way, that kind of stuff. So what they do is they just have a weld symbol. This is what you might actually see on a drawing. Probably should be on your drawing. But if I want to just not see it, I can go to View, Hide Show, and go down to it's gonna not weld bead, but annotation. Where'd it go? Oh, top level annotations. That goes away. Okay, so that's how we're going to deal with the welds, and I'm going to be looking for that too. All right, back to this one. Okay, so just going to be very quickly looking and making sure that all of your got a minus sign. That's not okay. So what's going on with that? So, but I'll sketch out this one here, of course, 10mm. And this one here is 6.5. See, that's why I got confused, and I did that one at 6.5 because you need the bits to be 6.35 so they fit inside, because you can't have them the exact same size because they'll actually won't fit. You have to have some clearance there to make them slip in and out. All right, and making sure they're all like lined up down the middle and stuff like that. And now what do we got going on here? Okay, this, if I haven't got this correct, this is a tough one to look at. All right, I have a minus sign, but I can't figure out what's wrong. Okay, I look everywhere here. I don't see anything blue, so I'm going to hit this zoom to fit. Maybe there's something way out in the distance over here that if I hit zoom to fit, it's going to show up. Well, it didn't. Okay. So where is the blue problem? And you might get really, really frustrated, as did I. Remember, I've gone through all the same stuff you guys have. But if I remember this correctly, there is a line somewhere beneath this line, and you right click and you go to select other. No, there's not that line. Okay. I thought there was a line somewhere nearby. Nope, only a single line there. No, single line there. All right. So what I'm going to do is I'm going to mess around with this. I'm going to delete this here. I'm going to move this around. Oh, wait a minute. Look at this. Somehow I have an extra line that just showed up. I knew I had an extra line. I have no idea where this came from. It's just sitting there. So I'm going to undo a couple things. So this, aha. Okay, here here's my extra line. And I'm going to delete that. Notice how the minus sign goes away. Makes me happy. And I am done with this. All right, so hopefully I covered all the things that are in this checklist here as well. I'm going to go to checklist here. So if I go up here, half sketch, dimensions, hexagonal sketch for the cut, and so on. Square shaft, the bump should have the right dimensions, and is it mirrored? Fillets, okay. Make sure the dimensions right, and talk about the sketches centered on the origin. And there's that minus sign that we didn't want, and the 6.35 there. All right, so the Phillips insert's a little bit more complicated. I looked at that. And the hex insert, I'll leave it find. And does it go from hex to circle to hex? Watch out for this thing. Okay, the shaft assembly, gotta, is the weld visible and reasonable? Notice how I don't necessarily put a number in on it, but there you go. Okay, shaft assembly, full assembly, and I went over, I'm pretty sure, all of those things to make sure there's no minus signs, fully constrained. All right, configurations available to see. And then there's the full assembly detail drawing, talk about the link to property using the metadata. And then there's that detail drawing. And I'm going to also add in is the weld symbol shown. All right. All right. So that does it for how the grading is going to go on this. If you have all these things, all these elements, you should have no reason not to get 100, unless, of course, you copied from somebody else, in which case that was a big waste of time. Okay? I hope you learned something, and I really hope you're on time, that you're getting this stuff done. I hope that you can ask some questions. Ask questions before you say you're ready. All right, so say, hey, I've got some questions on this, and then we'll go back and forth. You can fix some things, and then send it back to me for an actual grading session. Okay? Have a good day, and I hope this helped.